So I want to start off here comparing two different questions. I want to compare these two different questions. So this first question looks exactly like something we would have done in chapter 4, right? Right? Yeah. P.S. By the way, the chapter 4 tests are graded and posted, if you didn't notice that. All right. So to do a problem like this, sine inverse of 1/2, what I'm going to do is I'm going to go to my unit circle, and I'm going to locate the y coordinates where we have the value 1/2. So that happens at pi over 6, and also again at 5 pi over 6. However, both of these are not values, or not our answers, because I know that the fundamental range for sine inverse is negative pi over 2 to positive pi over 2. So only pi over 6 falls in that range. So this would have one answer. Everybody kind of remember doing that last chapter? Some of us maybe more so than others then. If I'm trying to solve this equation for x, I would, to get the sine, or the x by itself, I have to cancel out the sine. To cancel that out, I'm going to use sine inverse to both sides. And I'm left with that x is equal to sine inverse of 1/2. Which again, just like I did before, I go to my unit circle and I locate the values whose y coordinates are 1/2. Are both of these answers? Yes. Why is this problem different than the previous one? This is asking explicitly for the values of x, that when I plug them into sine, I get 1/2. That's true for both of these. Even though I use sine inverse along the way, that doesn't disrupt, like cause me to throw out those other values. In fact, are there other answers other than these ones? Yes. How many answers are there? Infinitely many. Because any angle coterminal to this one, which I can get by adding 2 pi to, is also an answer. Similarly here, if I add 2 pi to this one, I get another answer, and another answer, and another answer. There's infinitely many of them, right? Is everybody okay with that idea? So the trick to solving these, or the complication we have with solving these kinds of trigonometric equations, is making sure we get all of the solutions. So one of the types of questions we'll ask when solving these, or actually really when solving any trigonometric equation, we have to give you an interval of values of x over which to solve. Right? Because if I don't, well, I mean, I could list all the answers or describe all the answers using like a clever formula or something. But oftentimes you're going to be asked for all the answers between some values. So let's look at some examples here of doing this solving process. So let's say we're asked to solve for x the equation cosine squared x is equal to 1 for x between 0 and 2 pi. Okay. So what's my first step here to solve this for x? I got to get rid of the squared, right? How am I going to get rid of the squared? Square root both sides. What do I have to remember when square rooting both sides? Yeah, it generates a plus or minus. So I really have two separate equations here to solve. I have the equation cosine x is equal to 1 and cosine x is equal to negative 1. Everybody's okay with that? How do I solve cosine x equals 1? I take the cosine inverse of both sides, right? So that leaves me with x is equal to cosine inverse of 1, and x is equal to cosine inverse of negative 1, respectively. I'm now going to go to my unit circle and look for the places where cosine is equal to 1 and where cosine is equal to negative 1. If I go to my unit circle, I know cosine is the x-coordinate. So cosine is equal to 1 at exactly one location right there. That's the value when x is equal to 0, or where the angle is 0. Sorry to say. What? And cosine is equal to negative 1 at this location where the angle is pi. Everybody okay with that? If I look at anything coterminal to 0, it's going to be bigger than 2 pi and less than 0, right? Well, if I look at the interval, notice it's a parenthesis on the end, not a bracket, so 2 pi is not included in the interval that I'm looking for. I know that's chintzy, but good point. Similarly with pi, right? If I add 2 pi or subtract 2 pi, I'm going to be outside of the interval. So this answer, or this question, has exactly two answers, 0 and pi. Okay? But 2 pi is not inside of our answer set that we're looking for, because we're looking for 0 to 2 pi with the parenthesis. So 2 pi is not included in our set of answers that we can choose from. 0 has the bracket, so 0 is included. So we'd use 0 here as opposed to 2 pi. If instead this, say, was this, then the answers we would have listed was pi and 2 pi. Okay with that idea? Or let's say that this was negative 2 pi to 2 pi. What would have the answers I listed there be? So I'm still going to have 0 and pi, right? And 2 pi, the positive 2 pi. And negative pi. Right? So I can subtract 2 pi from this one, and I could add 2 pi to that one, and they'll get answers that fall inside of there. Okay? So once you find your answers for things between 0 and 2 pi, regardless of what we do to the interval, you can find the rest of them by just like adding and subtracting 2 pi's from it. Everybody okay there? What if we do one extra variation? And we say this. How many answers do I have now? Infinite. So we're not going to be able to list them all, right? What we're going to do is describe them. So I know one set of answers is this 0 radian angle and everything coterminal to it, right? The way I write that is I'm going to say 0 plus 2 pi k, where k is an integer. What that's saying is I can take the 0, and if I add any whole number multiple of 2 pi to it, I'm going to get another answer. Or a negative whole number multiple of 2 pi, I'm going to get an answer. Everybody okay with that idea? That that's just the way we're going to write all the angles coterminal to 0? And similarly, we can write pi plus 2 pi k. And that's how we would write it if we wanted all the solutions possible. Everybody okay with that idea? That's not so bad, right? That's just the notation we'll use to represent everything coterminal to the given angle. Let's do another. Oh, thank you. All right. So if I want to solve 3 tan squared x is equal to 1, what's the first thing I should do? Divide by 3. Good. Then what? Square root both sides. When I square root both sides, what do I have to remember? Plus or minus. And how do we square root a fraction? Yeah, you square root the top and the bottom. The square root of 1 is just 1. The square root of 3, though, we can't do anything with. Is that the way we want to leave that, though? Probably not, right? Let's rationalize this. We'll write it as root 3 over 3. Everybody's good at how I did that? Yeah. Yep. Okay. And then so to solve this, that's going to turn into 2 separate equations. Tan x is equal to positive root 3 over 3. And then tan x is going to equal negative root 3 over 3. And we can take the tan inverse of both sides. Everybody good there? Okay. To find my values of x now, I'm going to go to the unit circle and look for places where tangent is equal to root 3 over 3. Remember, how do I find tangent on the unit circle? Y over x, right? So, where am I going to get 1 over square root 3? What'd you say? 2 pi over 3. Okay? So if I take that, that's going to give me this negative square root of 3. at 2 pi over 3, right? Let's write it out just so that everybody can see. Because this is, again, not the easiest thing in the world. So we have, this, which is root 3 over 2 times that, which is negative square root 3. So that's not quite what we want, right? Everybody can see that? Let's go back and look at the unit circle again, but you're on the right track. What do we want? We want the square root of 3 in the x coordinate, right? So we want like 5 pi over 6, 7 pi over 6, and 11 pi over 6. Everybody agree with that? So we get here pi over 6, and then 7 pi over 6. This one was 5 pi over 6, and 11 pi over 6. And hopefully it's clear that if I add 2 pi to any of these, since they're all positive values, they would be bigger than 2 pi and outside of the desired range. And since all of these values are less than 2 pi, if I subtract 2 pi from them, they'd all be negative and be, again, outside of the desired range. So this is all of my answers, these 4. Everybody okay with that idea? If I looked at anything coterminal to these. Right? Because if I had to add 2 pi, they'd be too big. And if I had to subtract 2 pi, they'd be too small. Everybody okay there? What if I had asked for my range of values to be that? So we wanted negative pi to 4 pi. So obviously those 4 are going to be there still, right? Everybody agree with that? Okay. And if I add 2 pi to each of these, those answers should still be there, right? Those will be still less than 4 pi if I add 2 pi to each of those. We agree with that? 17, and then 23. Okay. Now if I subtract 2 pi over 6, because I have some negative stuff I could get too, right? That would give me a negative 11 pi over 6. That would give me negative 5 pi over 6, and negative 7 pi over 6, and negative pi over 6. Are all of those okay answers? No. Which ones are bad? That's too small, because that's less than 1 or negative 1 pi for sure. And also negative 7 pi over 6. That's also too small. That's also less than negative 1 pi. So that's what our answers would look like for the blue. Everybody okay there? So again, the hard part is getting those answers between 0 and 2 pi. Once you have those answers, generating any other solution set you might be asked for is pretty easy to do, right? You're just finding stuff that's coterminal. Cool? Let's do one more. So, to solve 2 cosine squared x plus cosine x minus 1 equal to 0, what should I do first? Not add 1 to both sides. What if we think about this? What if we think about it this way? How would you solve something like that? Oh. Oh. You guys, I'm so disappointed. I know.
I heard someone say that. I said it.
Factor, or you could use the quadratic formula, right?
You could do that.
No, that's what you should do. Let's factor this because this is factorable, and it'll be a good review to talk about how to factor something again, since apparently everybody forgot that was even a thing that you used to solve quadratics with. Oof. It's like the most important skill from your Algebra 3-4 class last year, but I guess you had a crappy teacher. That was me for most of you. All right. So to factor this, I need to find 2 numbers that multiply to give me A times C, and then add to give me B. What is my value for A here? 2. What's the value for C? -1. And the value for B? 1. What are the 2 numbers that multiply to give you -2 and add to give you +1? Taking too long, guys. 2 and -1, right? Oof. I mean, you can use that as an excuse, but man, it's one heck of an oof. Did you? You said 2 and 1. That's not 2 and 1. Thank you, Angeli. You just need to be louder. When you know you're right, just scream it over top of all the wrong answers. I mean, if they're right answers, I won't complain that much. Yeah, I'll be like, well, that might have been a little excessive, but I mean, I don't want to dampen your excitement. All right. So what do we do with these 2 numbers then? We're going to rewrite y as 2y plus -1y. And then we're going to make 2 groups with the plus sign in the middle and take a greatest common factor from each group. What's the greatest common factor from the first group? 2y. Greatest common factor from the second group? -1. Okay. Then what's the greatest common factor between those 2 things? Y plus 1, which leaves me with 2y minus 1. So there we're factored. To solve this when it's in factored form, what do? Set each piece equal to 0, and then solve. If you're factoring it, you should. Okay, now we're done, right? Wrong. What are we solving for? X. What have we solved for? Y. What do we need to substitute back in? Cosine x, which is equal to y. Everybody okay there? Now it's unit circle time, right? Where is cosine equal to -1? On your unit circle? Pi is correct. Sydney mouthed it. That's why I went ahead and said the answer. I saw somebody. You didn't scream it. When you know you're right, let us know so you can get credit on the video or whatever. Yeah. Now Marku's invested. Now he's invested. Yeah. All right. What are the values for x for cosine inverse of a half? Pi over 3 and 5 pi over 3. So we have 3 answers there. Does everybody feel reasonably okay?
Yeah.
All right. We're stopping here.